We'll solve the Irodov problem 152 of chapter 1, 1.1.152. In the other lecture, I have done it using simple harmonic motion. That is slightly a lengthy solution. I'll do a shorter version here. Such problems where there are two masses and connected by a spring always you can follow the concept of center of mass. Now, if suppose x1 is the initial location, x1, x2 are the locations at any point of time, not the initial. From any reference, what is the center of mass? Center of mass is m1 x1 plus m2 x2 upon m1 plus m2, that is from that location, from this reference point, from where we are looking, this reference. Now, velocity of center of mass would be equal to m1 v1 plus m2 v2 upon m1 plus m2. And what is the acceleration of the center of mass? In this case, we can double differentiate it. We can get acceleration of center of mass is m1 a1 plus m2 a2 upon m1 plus m2, that is there. And we can also use this formula, force is equal to mass into acceleration of center of mass, to get the center of mass acceleration, and this is the total mass. So acceleration of center of mass here would be F is the force acting on the system, and total mass of the system is m1 plus m2. So if we look at this system in the frame of reference of center of mass, we can draw it like this. So these two masses being seen, this is the frame of center of mass. This is the frame of center of mass, and these are the ends of the spring. Now, what is the force which is acting on these two ends of the spring when we look at the frame of center of mass? Now, since center of mass frame is moving with acceleration a center of mass, we have to add the concept of pseudo forces which will be acting here, and we have to find out maximum distance, that is maximum elongation. And at the time of maximum elongation, the spring will behave like a string, because there is no further extension possible. Means at that time, velocity of center of mass would be equal to velocity v1 with respect to center of mass, and velocity of v2 with respect to center of mass. Means center of mass is moving with certain velocity v center of mass, and they are also moving with the same velocity. Means the relative velocity of relative v of 1 and 2 in this frame, center of mass frame, with respect to center of mass is 0. So whole system is moving with the same velocity as if like a string. Now, if you look at the two ends, I'm just thinking the spring to be a string. Now, what are the forces which are acting? The force acting here will be the mass m1 times the center of mass acceleration m1 a center of mass. And what is the force acting here? F. And then this is the pseudo force, this was pseudo force. Here we are looking at the external forces. While we are solving the center of mass reference frame, there is one internal force which is due to the spring. And what is the external force? Are at the ends, one is this one and the other is F minus m2 a center of mass. These are the two forces which are acting at the two ends. So the force here at this end is m1F upon m1 plus m2, which is acting in this direction, and force here is F upon F minus m2 F upon m1 plus m2. This is equal to F m1 upon m1 plus m2. So these are the forces acting at the two ends. Let the extension here be x1. Extension means the spring has the end of the spring, which was the initial position, and at this point of time the end is here. This was the initial length of the spring L0 before the force was applied. Now this is the new length. X2 got extended on this side, on M2 side, and on M1 side X1 got extended. Force applied here is F1 is this and F2 is this. Total work done by external forces is equal to F1 x1 plus F2 x2, which is equal to m1F upon m1 plus m2 x1 plus m1F. See, this is coming same in this situation. Both the ends forces is coming same. m1 plus m2 x2, which is equal to x1 plus x2 m1F upon m1 plus m2. So this is the work done by external forces. Forces when you are looking in center of mass frame, CMF I am writing. What is the kinetic energy of the system in center of mass? The two masses are not having any relative velocity in center of mass. So kinetic energy is 0 in center of mass frame. And what is the potential energy? Is the potential energy stored by the spring is half k x1 plus x2 whole square. x1 was extension on one side, x2 on the other side. Total extension is x1 plus x2. So this potential energy which is stored in the spring is because of the work done by the external forces, which is x1 plus x2 m1 F upon m1 plus m2, and this becomes, from this we can get x1 plus x2 is equal to twice m1 F upon k m1 plus m2. If m1 is equal to m2, we get twice F. This is not f1, it is twice F. Can write it again. Twice F m upon k twice m is equal to twice F upon k when m1 is equal to m2. Twice F upon twice k, or which we can write as F upon k. So the maximum extension of the maximum separation between the two masses will be the undeformed length of spring, this is L0, plus twice F m1 upon k m1 plus m2. This is the general formula, and when we place special case, when m1 is equal to m2, we get L0 plus twice F, as I've already done, m upon k twice m is equal to L0 plus F upon k is the maximum separation, and minimum separation will be when there is no elongation in the spring. In this case there will not be compression because the force is outwards, so the minimum separation would be L0 only. So that's the